This includes three things. First, the introductory questions, algebra of events, and the most important Bayes theorem. So there is, make sure that you are able to understand each and everything, and keep asking as many questions as you want. Okay, so that I'm able to understand what you are you are able to understand or not. And make sure that you cover the questions from the Bayes theorem specifically, because it's very important, and it always comes, Bayes theorem is always there in the exam, and it's very important. Secondly, the portion of basic probability, it's very simple as compared to other portion that you are going to attempt in the exam, right? So, and as far as the competition, okay, so we'll talk about that later, but since this is the basic probability, so make sure that you are able to attempt the questions that come from this section. Okay, so that the marks on this portion are sure to you. Okay, and the level of questions that you are going to cover from this, they're not very hard, they're up to your level only, not very difficult. And as far as the level of competition is concerned, if you are able to, they in any exam, you give any exam, so there is always some questions which are simple, and some are moderate, and some are difficult. So a question paper always has these kind of questions. Some are very simple, some are moderate level, and some are at difficult level. So in this particular exam, if you are able to do only the simple and the moderate questions, okay, if you are able to cover only that portion also, from that portion also, you can easily qualify this exam. Okay, now by qualify, I don't mean that qualifying the cutoff only. By qualifying, I means getting into IITs. Okay, so only if you get the easier portion and the moderate portion, just even if you're not able to do those 2-3 questions which are very difficult, because they hardly strike to a person when he's there in the exam, even then you are going to. But the fact is that even the simple and the moderate also, the fact is that even the students are not able to do those questions also, the one which are simple and moderate. Okay, so but in this lecture series we'll be doing every type of a question. There's no doubt we'll be solving some difficult, moderate, and easy, every kind of a question. But I'm just giving you an idea about the exam, that if you are in the exam and if you are able to do all the simple questions and all the moderate, so make sure that you, whenever you sit for the exam, you are able to do all the simple questions and all the moderate. That's sufficient to get into IITs. Okay, this is just the idea that I want to give to you people.
Okay, sir.
Okay. So let us start the class. So these are very introductory terms. You must have heard about these also. We'll just go through them very fast. So first thing is the random experiment. Any experiment conducted under identical conditions whose results are not unique, or any experiment that has a random results, they are called as random experiments. For example, tossing of a coin. Okay, the sample spaces, the head and the tail. So these all are random experiments. Throwing a die. So the sample space, we all know it's a famous sort of a problem. It has a sample space 1, 2, 3, 4, 5, 6. Then selecting a vowel randomly out of a set of vowels, this which gives you the following sample space. So these all are random experiment. And what an outcome is, the result of a random experiment is called as an outcome. The trial conducting a random experiment, it is called as a trial. And any outcome or a combination of outcome is called as an event. So event is very important thing, because we always find the probability of an event only. Okay, we define an event and we find the probability of those events. So the exhaustive events are the total number of possible outcomes. Mutually exclusive events, very important. If the occurrence of one event results in the non-occurrence of other, then that is a mutually exclusive events. For example, in case of the coin tossing experiment, we have this particular sample space, then both head and tail, they are mutually exclusive. Okay. Can you guys think of any other example of a mutually exclusive event? Anyone?
Sir, win and loss.
Can you elaborate this example? Your approach is correct.
If we remove the possibility of tie, like if one person is winning, the other person loses. So cannot be.
Yeah, that these events are mutually exclusive. So if one happens, it excludes the other. Equally likely events, the outcome of a trial, it is not trainer, it's a trial. The outcome of a trial is said to be equally likely if they all have same chances of occurring, right? So for example, in the experiment of throwing a die, okay,
Nice. Nice.
so they all have an equal probability. Similarly, in this also, on a coin tossing experiment, they both are equally likely. If the coin is it's not a biased coin. For an unbiased coin, each of the event has a head or tail. They both have same probability. So if they all the events are they have same chances of occurring, then the events are called as equally likely.
Yes.
Independent events, another very important thing. Independent events, if the happening of one event does not depend upon the happening of other, right? So on one side, suppose you are tossing a coin, and on the other side you are throwing a die. So whatever appears onto a die has got nothing to do what's going to be appear on the coin. So they both are independent events. So if one does not depend on the other, the events are independent. Can you think of any other example of an independent event? Anyone? Just think of one more example, so that I ensure that you are able to understand what independent events are. Okay, suppose if I toss a coin over here and you also toss a coin over there, is there any link between my coin and your coin? Are not both the coins independent?
Yes.
What is going to appear on my coin has got nothing to do what's going to appear at your end, right?
Yes, sir.
Yes.
So these are examples of independent events. Sample space, you must be knowing the set of all possible outcomes. Okay. In the previous slide, what we have seen, these all are sample space. Okay. Suppose if I throw a die and my interest of event is the odd numbers, then what will be my sample space?
Odd number. 3,
1, 3, and 5,
1,
right?
3, and 5.
Yeah. Now the probability function, the number of favorable cases divided by the total number of cases. This is how the probability is defined. Any doubt till here? Anything? This is just the revision of whatever you must have studied in your statistics course.
No doubts.
Yeah,
Yes.
as far as the basics are concerned and the level of questions also concerned, you can, without any doubt, you can consult NCERT books. Even the level of questions, even the base theorem also, the questions which are given in NCERT, they are good quality questions. So for clearing the basics, you can go for it without any doubt. It's a good book to cover.
Yes.
You can solve questions from that up till conditional probability and those all. But yes, as far as the discrete random variables, continuous random variables are concerned, so in NCERT, they do not introduce the concept of the types of random variables. So that we have to study from the other sources. Okay, so as far as the basic probability is concerned, you can consult NCERT books, no doubt. Okay, so this says two unbiased dice are thrown. Write the sample space and find the probability that both the die show the same number and the first shows up an even number. So we are going to solve it one by one. This question came in UP Assistant Statistical Officer exam 2016. So this is how the sample space will look like, right? If you throw two unbiased dice, okay, then this is how the sample space will look like. Is everyone clear that why we have this as a sample space?
Yes, sir.
Okay. So both the die show the same number. So they all the pair, they are, it's a very famous sample space, and I think you all know that they are all together are 36 pairs, right?
Yes, sir.
Entire sample size has a size 36. Now you must be familiar with it. If you know, then you can count and just remember this because it's a famous sample space. All the pairs in number, they are 36. If you count 6 times 6, that will be 36. Okay. So if we define the event as A, that both the die show the same number, then the probability of A would be, now both the die showing the same number,
One,
we
one.
are only on the diagonals that have the same number.
Six.
So there are 6. So this will be 6 by 36, that is 1 by 6. Okay, it's simple. Is it clear?
Yes. Yes, sir.
Okay, can you think of the second? What will be the answer for the second?
1 by 2.
So this says that the first shows up an even number. So out of all the pairs, they are saying that the first die must show the even number. So we can see that from the first row, from the third row, and from the fifth row, the first number is always an, there
Right,
first
second,
even number. So the
fourth
second
row and sixth row.
from the fourth row and from the sixth row. Okay. So this entire row has a first number even. This entire row has a second first number even, and this entire row has a first number as even. So there are total they will be 18 cases, right? 6 from this, 6 from this, and 6 from this. So the probability of this event will be 18 by 36. That is 1 by 2. Is it clear? Any doubt in this?
No, sir.
So let us see the other question. Two fair dice are tossed independently and it is found that one face is odd and the other one is even. Then probability that the sum equals 7 is. So think of this question. How you are going to solve it? The sample space will be same. Two fair dice are tossed, right? So the sample space will be same. The probability that the sum equals 7. The sum must be 7. So let me show you the sample space again. Okay, this is your sample space. And this is
1 by 12.
this is not the actual sample space. So this is, we have to derive the actual sample space, right? They are saying that two fair dice are tossed independently and it is found that one face is odd. So our actual sample space will look like that, all those cases where one face is odd and the other one is even. So one has to be odd and the other one has to be even. So if you look up to the first row, then there are total how many cases of one being odd and the other being even? There are 3 cases, right? Where you have
But sum is equal to
other
7
even.
in one
Similarly,
case.
in the second row, you will find 3 cases where one is odd and the other one is even. Similarly, from this also 3, and all they have 3. So there are total 18 cases in our sample space, right?
So first dice have odd number, both have odd.
Huh?
Only first dice have odd number, even
Not
both
first.
have.
One is odd and the other one is even. One face is odd and the other one is even.
Okay.
One of the face has to be odd and the other one is even. Okay, read the question carefully. Are you able to understand the question? They are saying two fair dice are tossed, right? And it is found that one face is odd and the other one is even. Not the first face. One face is odd. Okay,
sir.
one face is odd and the other one is even. So it could be the first or second, anyone. Okay, one of them has to be odd and the other one has to be even. So if you
Okay.
look to this sample space, are you able to understand the question?
Yes, sir.
Okay. So in the first row, we have 3 such cases where, see, in the first row, the first is always the odd. So we have to look for the other one which is even. So this is this particular case, this case, and this case. So there are 3 cases in the first group, right?
Yes, sir.
Similarly, the second, we have
2, 3, 2, 5, 2, 1.
there are 3 more cases, right? Similarly, in this also you are going to have same 3 cases, one with the evens. In this, the odd ones. Then in this, the evens, and in this, the odd, right? So there are 18 cases in the sample space.
Yes, sir. 1 by 6, sir.
Okay. Now we have to look for the cases where the sum is 7. Now the sum 7 is going to come for 3 and 4, right? 4 and 3. Then 6 and 1. 1 and 6. 5 and 2. 2 and 5, right?
Yes, sir.
So the answer will be, so there are 6 cases.
By 6.
6 by 18. So this will be 1 by 3. See the solution. Let me know when you are done.
Yes.
If you have any doubt, just ask me. Are you guys done?
Yes, sir.
Okay, so this is from 2019. Read the question very carefully. 2 fair dice are tossed independently and it is found that one face is odd and the other one is even, just as in previous case. Okay. Then the probability, round off to 2 decimal places, that the sum is less than 6. Okay. First, read the question. Let me know, have you understood the question or not? 2 fair dice are tossed independently and it is found that one face is odd and the other one is even, just like in the previous question. Then the probability, round off to 2 decimal places, that the sum is less than 6. Have you understood the question?
Yes, sir.
Okay, just try to solve it. I'm giving you some time. Let me know what your answer is. Okay, how we are going to do this? Anyone? How we are going to solve it?
Sir, sum is less than 6 is 1 minus sum is equal to 6. So I think the sample space will remain the same. We have to check the sum is equal to 6.
If you take 1 minus sum is equal to 6, then that will take cases which have a sum greater than 6 also.
Okay.
Okay. The sample space, first we have to derive the sample space. As discussed in that particular question, the sample space would be same, right? From this particular structure, we have to derive the sample space. Now, first, the sample space contains of only
Sir, 70 by 80. 7 by 80.
first we'll take the sample space, okay, where it has only those values which have one face odd and the other one is even. So from the first case, just like in the previous question, we have 3 cases here. Similarly, here we have 3 cases, right? So there are total 18 cases. Is it clear? In your sample space, you have 18 cases. Is it
Yes,
clear?
sir. Yes, sir.
Yes, sir. Yes, sir.
Okay. Now, amongst these 18 cases, we have to look for those cases where we have sum less than 6. Okay. Amongst these 18 cases, we have to look where the sum is less than 6. Less than 6. Okay. Not equal to, less than 6. Okay. Is 2 and 3 going to be there? This will be there.
Less than 6.
3 and 2 will be there. 1 and 4 will be there. 4, 1 will be there.
6 by 18 or 1 by 3.
Okay. Any other case? Okay. 2 and 2 cannot be there because they both are even, right? 1 and 2 cannot, 1 and 2 can be there.
3 and 2.
2 and 1, this can be there. The sum has to be less than 6. 1 and 3 will be there. 3 and 1, this will be there. Is it
No,
clear?
sir. 1,
Any-
3 and 3.
We cannot have 1 and 1, right? Because
Sir,
they,
1, 3 and 3, 1 कैसे?
huh?
1, 3 and 3, 1 कैसे होगा? One face is odd and other one is even.
One, yeah, this won't be there. 1 and 3 cannot be there. Okay. This won't be there because they both are odd.
Okay. Only 6 cases.
So there
6
are
by
6 cases.
6
So
by
out
18.
of
1 by
those, we have 6 upon 18, which is 1 by
3.
1 by 3. Okay. So round off to 2 decimal places, the answer would be 0.33. Is it clear? See this question. When you are done, let me know.